All right, hello, and welcome back. My name is Ryan England. I work for Vision Data and Communication Services, and today we're going to be talking about network terminology. All right, network terminology. So, common terminology we use when we're talking about a network, at least in these days, we talk about something called a PBX and an MDF, an IDF. Within networking, we also use terms for cabling, right? The jack and a port, an RJ45 and RJ11, Cat5 or Cat6. Right, these are all terms we use to describe or talk about a particular entity of networking. All right, so without further ado, if you notice, I've changed positions. I'm up here somewhere, so hopefully you can be able to see a little bit more of the screen. All right, so without further ado, let's go ahead and jump into it. We're gonna start with PBX. Right, this is the private branch exchange. All right, you don't need to know really that word or that term. Just know PBX is it's an exchange. Okay, X stands for exchange. So what's it for? All right, this is referred to as a room or a location within a business. Okay, it connects. All right, connects a business's telephones to a telephone service. Okay, so um, typically what you'll have is a main hospital that has a PBX room, all right, that all the other hospitals connect to or clinics connect to. But this is the main place where telephone service meets hospital network. Okay. Why? Why do we have PBX rooms? PBX is standard for connecting telephones to telephone providers. So you got to connect somehow, right? And this is the place they do it. Usually it's under lock and key. And even so, the PBX room is under lock and key. And then the actual telephone service box is under lock and key also. Okay, so very secure area. Um, but that's the PBX room, all right? Private branch exchange where a lot of the connection happens between telephone service provider and hospital network. Okay, the next room is the MDF, right? Which is a room. It's a main distribution frame, right? But MDF, it's a room. Okay, um, it's the main place where all telecommunications data and calls come to. Okay, it's not necessarily the PBX room. Okay, all right, it's just the main room, the main distribution room where all the telecommunications data and exchange things happen. Okay, within a building. All right, so the MDF is typically a place where a lot of analog work is done, where you'll see a lot of 66 and 110 blocks, and we'll talk about those in another video. But typically, a lot of analog work is done in these rooms. A PBX room can be an MDF room. Okay, but an MDF room is not necessarily a PBX room. So make sure you know that distinction. PBX room can be also an MDF. All right, but if you have an MDF, you're probably not going to have a PBX room. Okay. So the last room we'll talk about, we'll talk about this distinction a little bit in a second. But the last room I want to talk about is the IDF. Okay, this is the independent distribution frame room. Okay, and this is just a data closet typically. So you have your MDF, which is maybe in the basement of a hospital. All right, the main room, the main distribution frame. And you have an IDF, which is like the data closets on the first, second, third, fourth, fifth floors. Okay, and so again, these are just to be another place for the connection to work on a connection from a device. So, for example, if you have patient rooms, all the patient room phones are analog phones typically, and they'll end up going to the IDF room on the third floor, let's say. So if a wire is eaten up by a mouse in the ceiling or something, you don't have to trace that wire all the way to the MDF. You can just trace it from the IDF to that patient room and recognize, oh, it's cut somewhere between the IDF and the patient room, and just repair, 20 feet of cord rather than 100 feet of cord. So it's just another segment of the network going to the telephone service that you can work on. So it's independent, right? It's on its own. So independent distribution frame. Um, and typically there's one on every floor or one in every section of a hospital. Okay. So just as an example, to tie this all together, PBX, MDF, and IDF, all right, these terms will be thrown around with each other. So if we have a main hospital, okay, and that hospital has the hospital network, and that network is connected to a clinic, right? And it's connected to another clinic and a hospital, a different hospital, under the same business, but maybe it's a smaller hospital somewhere, and connected to another clinic, okay? This is how typically it's set up in terms of PBX, MDF, and IDF. Okay, so take a minute to look at this page here. We have the main hospital. All right, and I'll just choose a random hospital like I think in Indiana there's one, Franciscan, right? So Franciscan probably has like a main hospital, and we'll say it's Indianapolis, right? All right, because that's the capital. So the main hospital is in Indianapolis. All right, the main hospital will have the PBX room. All right, the main exchange between the telephone service and the hospital's network. Okay. All right, that PBX room can be the MDF for Indianapolis. Okay. So, but it's connected. All right, that PBX room is connected to a clinic, and a clinic has their own MDF. Okay. And the PBX room is also connected to this clinic, which has its own MDF, and this clinic which has its own MDF. And it also has this, the PBX room is connected to this hospital that has its MDF and IDF on different floors. Okay, so hopefully you're getting the picture here that the MDF is like the main data closet for a clinic or a hospital, whereas the PBX room is like the main room to switch between telephone service and home network. So routing, rerouting calls from outside into the hospital's network, and then routing those to MDFs depending on where that clinic or hospital is at. One other thing to note, a hospital like Franciscan can have more than one PBX room. Okay. So that might be a little strange, right? Why would they have more than one? Okay. In case one fails, or also in hard to reach places. Okay. So they may have one in Indianapolis, right? And they may have a PBX. They may have a main hospital in Indianapolis, and then they have a main hospital in Olympia Fields or something. Okay. Those are very far away from each other, right? But they're used just for that reason, to kind of collectively cover a region, right? So there won't be more than one PBX room in one hospital, but for a whole hospital system, like throughout the state, there may be more than one PBX room to cover those remote clinics or cover those areas. Okay. So hopefully that makes sense. All right. Every hospital or clinic will have an MDF usually. And then a big hospital will probably have a PBX room. Okay. All right. So let's just take a look at the diagram here, and I'll show you how a call is routed through all of this. Okay. So we get a call from an outside number, and it wants to call Sharon. All right. And that call routes through to the telephone service into the hospital's network, and it meets Sharon. Right. So how does it? What does it travel through to get there? Right. So let's look at that main hospital network part. Okay. So we get the call, it goes to the telephone service, it comes down, and it goes into the PBX, which then routes to the MDF. Okay, so PBX from this main hospital, and it routes to that MDF. All right, so let's say the call Sharon is in the clinic here. All right, goes to the telephone service, comes to the PBX room, boop, all the way to Sharon, or all the way to wherever Sharon's office is in this clinic, so to the MDF, and then all the way to Sharon. All right. So telephone service, PBX in the main hospital, MDF in the clinic, all the way to the IDF on the 3rd floor where Sharon's phone is, and it goes to Sharon. Okay, so all these rooms, PBX, MDF, and IDF, are used to route a call to Sharon or route a call to any phone within that network. All right, so that does it for your networking terminology. All right, we talked about 3 rooms: the PBX, the MDF, and the IDF. All right, last thing we're going to talk about in this terminology series here is cabling. Okay, cabling within the network. We typically refer to a jack as an RJ45 or an RJ11. So let's kind of dig a little deeper into that. RJ is a registered jack. Okay, registered is just, it's registered with the IEEE standard. IEEE is a group of electrical engineers that set basically the laws and rules on low voltage technology or pretty much anything related to computers. So registered means registered jack. All right, this is within the IEEE standard. Okay. All right, so RJ is, again, the standard. Okay. An electrical connector that connects a telephone to a port or a pair on the telecommunications network. So these jacks connect ports to telephones or ports to computers or whatever. Okay. It's kind of like a middleman. All right. A jack is a middleman between the hospital network, and the telephone or the computer. Okay. So why are jacks used? Again, it's to segment, all right, the connection from telephone or computer to the network. So if something breaks, you're not running 100 or 1,000 feet of cable between the network and the phone. You only, if it breaks in one particular segment, you only have to fix that segment. Okay. These jacks are standardized by the telephone gods, or the IEEE people. So they're used everywhere. All right. There's 2 jack types that we would be focusing on typically, and it's the RJ45, so registered jack 45. All right. These are 8 pin jacks. All right. Or if you see these metal strips, these are called pins. Okay. And there's 8 of them. Okay. And then we have RJ11, which is a 4-pin connector. So there's 1, 2, 3, 4 pins, a little bit smaller, right? But again, we use these mainly with analog and POTS and fax lines. This is typically used for any type of IP device like a computer or a voice over IP or security devices like cameras, something like that. They'll use this type of jack, right? So those are jacks. All right. Along with jacks comes cabling that we plug into the jacks, right? Okay, so cabling comes in categories. Okay, so we have CAT or Category 3, CAT or Category 5, or Category 6. So again, with the IEEE standards, there's categories that meet specific needs for different devices. So Category 3 is typically your analog devices that don't really need that much power, or they don't need all that electricity or all that space for electric potential. They're very simple. As you get higher in category, they typically do more things or are able to handle more connections or more data transfers, whatever. So depending on what category you're in, will tell you what you can and cannot do. All right. So again, Cat 3 is 4-pin jacks. These are for analog. 5 and 6 is used for 8-pin jacks or RJ45s. In the Cisco 7841s and 8851s, they have the black cable. That is Cat 5e cable. Okay. And if you notice, it has some colors here. All right, so we have a green and white, a green wire that's twisted with a white wire. So it's two wires twisted together. Okay, so this is two wires here, two wires here, two wires here, two wires here. So we have green and white, orange and white, blue and white, and brown and white. So there's 8 wires, right? Or sorry, that's the Chinese way. 8 wires for 8 pins in the jack. So it could be said that, again, we have these wires here, same wires, 8 wires, orange, green, white, blue, white, green, white, brown, brown. Each one of these wires is made of copper, and they connect 8 wires to the 8 pins. Okay. Same with Cat 6. It's eight wires. All right, that go to 8 pins. Okay. So why again do they use these different categories? All right. Depending on the requirements of that device will tell you what type of category you can use for that device. Okay. So they're just used for different uses. All right. So one thing to note is you can use a so analog typically uses Cat 3. You can use analog on Cat 5, but analog will only use either 2 or 4 wires. Okay, so you would be disregarding the other 4 wires here, but you can use those other 2 to get there. So sometimes you'll see Cat 5e with analog, but it's very rare, although it does happen. Because they don't have any Cat 3, they'll just take a Cat 5e cord and kind of cut it in half, or only use 4 wires out of that 8 wire wrap, and use those 4 for just the analog device. The only difference with Cat 6 is it has some extra shielding in there, and it could do some other things that I'm. The only thing I do know that Cat 6 would be able to use better than Cat 5e is it can handle gigabit Ethernet. Excuse me, gigabit Ethernet. So and again, that's a whole other topic. There's fast Ethernet and gigabit Ethernet. Gigabit Ethernet is faster. Okay, so Cat 6 is qualified to have faster data running through it than Cat 5e. Cat 5e may be a little bit slower. So also typically when we go to a hospital, when we talk to IT and we show them how we set up the phones, and we use a black cable from the boxes, the Cat 5e cable, they'll say, no, we're not going to use that. We want you to use these other cables. And typically those other cables are Cat 6 or Cat 6A cables. And the reason why is because technology is moving so fast that Cat 5e probably won't be used, 10 years down the road, or maybe even 5 years down the road anymore. And everything will be running on gigabit Ethernet. And so they want Cat 6 to be there now while we're installing, so that they don't have to update that later. So just a caveat, but it does happen. All right. Last thing, Cat 3 is, again, 2 to 4 wires, or 1 to 2 pairs of wires. And it's usually flat. You'll see these in faxes, analog, and POTS devices. And then Cat 5e, Cat 6, and Cat 6a all have 8 wires or 4 pairs. And they're usually insulated. They'll have like some, like a plastic cross in between all the wires to keep electromagnetism from happening, really, or keep interference from happening for data transmissions. They'll insulate them to stop that. Especially with Cat 6, that seems to be more of the case. These are also called unshielded pairs or unshielded wires. Shielded is there is shielded wire also, and that's typically for like wire that is needs some type of shielding to really cut down on electromagnetic radiation or electromagnetic interference with data transmission. So, for example, if you're running a security camera cable to a security camera, and you run it through the ceiling over some lights, that light has electromagnetic waves and can interfere with the data signal between the network and the security camera. So they'll shield it to really stop that light from interfering with any of the data transmissions from the camera to the network. So we work in unshielded pairs or unshielded wire, but it is possible you might come across shielded wire as well. All right, we're going to stop here, okay? And so if this is where you're going to finish with the video if that's all you came for, okay? We're going to take a deeper dive into how it all works now, okay? So if you do not want to take a deeper dive and what you've learned is enough, stop here. You don't need to go any farther, okay? If you do want to go farther, stick with me and we'll go ahead and jump into a little bit of how the telephones work a little bit deeper, okay? So here we go. Again, stop now. Go get a drink. Go hang out. You've done enough. If you want a deeper dive, stick around. Okay. Making calls. All right. So let's just take an example. We have a outside call here. We have our telephone service, our hospital network, and we have some phones over here. Okay, connected to the hospital network. So let's say a cell phone calls this number, 837-1234. It routes to the telephone service, goes to the hospital, and calls that phone. Okay. I want to just jump into a little bit more of the hospital network and how it handles that call. So there's another term called a voice gateway or a VG. Okay. And what this is it is a gateway, and a gateway almost is like a translator. Okay. It takes data, or it takes a phone call and it translates it into data, and vice versa. So it'll take data, transfer it into a telephone call, and it'll take a telephone call and transfer it into data. So when we talk about voice over IP or internet protocol, we're taking voice and we're turning it into data, and vice versa. Okay. So that's what a VG does. It translates it. So within a VG, it has all of these phone numbers inside of it, right? At least when a whole bunch of telephones are connected to a hospital's network, it has all those phone numbers stored inside of its computer. So it knows all the numbers. All right. Okay. So we get a call, telephone service. It eventually goes to the hospital's network, which has a VG. All right. And that VG has an idea of all the telephone numbers within that network for that hospital. So one caveat about these VGs is there's a rule for how many calls it can manage at one time. So in this is an example for this VG. Let's say it only 2 calls at one time. So if 3 calls are made, it can only handle 2 of those until one of the calls drops. It doesn't only do that. A Cisco VG, a 450 will do like 144 calls at once, and then the 310s will do less than that, and so on and so forth. So it can a VG 450 can do 144 calls, but for our example, let's just say only 2 calls at one time. Okay, so we have these 3 numbers in a hospital. Okay, let's just say it's just these 3. We got Jim, Sharon, and Ted, and we have our voice gateway, and it only takes 2 calls at a time. So somebody calls Jim. All right, goes through the voice gateway, and in red here, Jim is on the call. And somebody calls Sharon, and Sharon here is on the call as well. Well, if somebody calls Ted, all right, this voice gateway can only hold 2 calls, right? So it'll keep ringing and ringing and ringing until either Sharon hangs up the phone or Jim hangs up the phone, or it'll go to voicemail. Okay, if it has voicemail on that phone, so it can only handle so many calls, right? And that's kind of what a VG does. That's why we put those VGs in. They do hook up to analog and they do hook up to the hospital network, but they can only handle so many calls. And based on how big the hospital is going to tell you what type of VG is needed. So for a bigger hospital, I was just at one last week. They had a new hospital that was 4 floors, and in their MDF, they had a Cisco VG 450 that can handle 144 calls, which makes sense because they have probably 400 something phones there. So they're covered. 144 calls made at one time. There's probably not going to be more than that. You can put VGs together. You can put a couple 450s or 310s together to kind of improve how many calls you can make at one time. But usually 144 will do it. Will do most smaller hospitals or clinics. 310s for small hospitals usually. 450s is probably more for the bigger hospitals. And these things are expensive. These are like between 10 and 15,000 something dollars. Like they're a lot of money. So it's just something to think about. Like, how can you make all these calls at once? Technically you can't. You can overrun a voice gateway, but it can only handle so much. All right. The other thing is directory numbers. All right. So that's VGs. That's kind of making calls and how the VG works with that. Directory numbers. Hospital's network has the VG, right? A directory number is only assigned to like a POTS line or a cell phone number. Okay, these are your directory numbers that are attached to the telephone service. So we do talk about DIDs a lot, and when you're working with voice over IP phones or any of the Cisco devices, we typically use DID because it's an inward dialing number. Directory number is typically for the emergency lines or any number where you need the full 10 digits that's not connected to the hospital's network. That would be a directory number. Okay. Just one other thing I want to compare is DID versus POTS. So again, you have your DID, which is connected to your business network. Okay, connected to the hospital's network. All right, this is cheaper. All right, it is cheaper for a hospital to connect these phones to the hospital network through the computers and assign DIDs than it is for them to have POTS lines. POTS lines are expensive, mainly because one, it's a directory number. It is from the telephone service, and the telephone service knows and keeps that number. They own it. DID, the hospital owns that number, technically. Right? Technically, the cell phone service still, or the cell service still, the telephone service still owns that number, but it's assigned to that hospital only. POTS lines are directly to the telephone service that are attached to the hospital. And they're expensive because they connect directly to the telephone service. Like, telephone service is taking all the weight from you and giving you this line. So as long as you don't cut it, they're taking care of everything else. So it is definitely more expensive to have POTS lines than it is a DID. Okay. Last thing, some other terms you may want to know is, especially if you're working in analog or if you're in the MDF or PBX room, there's something called the PRI. A PRI is just a device, all right, from the telephone service that acts just like a VG. All right, so we talked about VG, voice gateway, right, where it kind of turns data into It turns telephone calls into data, and data into telephone calls. Right? It's a gateway. PRI does the same thing. Okay, but it's owned by the telephone company or the telephone service company. Okay, so if you hear the word PRI, just think telephone service. Okay. The other thing you may want to know is something called a network switch, right? And this is a network switch here. They can be stacked like this, or they can just be single and look like this. All right. A network switch is exactly what it sounds like. All right. It switches. Okay. On a network, you have this device called the switch. All right. And it connects all the devices to each other so they can talk to each other. Right. It also, this device, a switch, can connect to the VG or to a router and route out data between your computer and the internet. Okay. So all of these are called ports. Okay. And on this one, there's 48 of them. And typically at a hospital, there'll be 48 port switches, and there'll be like 10 of them or something in a big hospital. But these ports all connect to either a device or a jack or a router or some other device to keep them all connected. It brings the whole network into play. Okay, it connects them all together. And typically, when we're deploying phones, they want us to plug the phone into the computer to get power from the computer. Why? Why do they need power from the computer? Why can't we just plug it straight into the wall? And in some cases, we usually do plug it straight into the wall. Well, these switches provide electricity to that RJ45 jack in the wall. All right, so there's a Cat6 cable connected to this port, and it connects to the jack in the wall, and then that jack goes directly to the computer or to the phone. Okay, if it goes to the phone, that switch needs to send power to that phone. So a lot of issues we come across is no PoE, right? No power. So if we're not plugged into a computer and we're just plugged into the wall with the telephone plugged into the wall and there's no power, it's because the switch is not sending power to that jack. Okay? Why? So power on these ports on the switch is programmed. Okay? The network guys, the IT people that have to actually get in there and take that Cat6 cable and plug it into a port that will give power, or they can program the switch to send power from that port to that jack. Okay. So typically when there's no power or no PoE and the phone is plugged into the wall, not the computer, but plugged into the wall, and there's no power, it's because this switch is not sending it power. Okay, so this switch can do a lot of things, but mainly it connects all the devices in a network together, and helps route traffic, route data, but it also will send electricity to those jacks to power up those devices or power up those phones. If you ever notice on a Cisco telephone, there is no power supply. It's because the power comes from the switch. And like I'm saying in our example here, the hospital or the IT team wants us to plug into computers because they don't want to take up a port on this switch to send the power. Well, why wouldn't they want to take up a port? Well, there's only 48 ports, right? They don't want to take up that port, and buying another switch is a lot more expensive for that hospital than just plugging it into the computer and getting power from the computer. And that's the whole reason voice over IP phones are so sought after, is because you can just put them in the computer and you get power, you get network. It's easy, it's cheap, and it looks good, and it's nice. You don't have to worry about plugging it in a whole new telephone into one of these ports, or you don't have to worry about expensive POTS lines or about cross connect analog lines, right? So voice over IP can also do additional lines, voicemail. You can change your ringtones, wallpapers. You can do hunt groups. You can program them. There's so much flexibility with voice over IP compared to analog or POTS, and it doesn't take up a lot of space or a lot of power or network devices. It's pretty self sufficient. Um, so just something to remember. A network switch connects all the devices in a hospital together that are hardwired, right? And typically, if you're plugging into the wall with a phone, it's being powered up by a switch, right? But 9 times out of 10, you'll be trying to plug it into a computer so it can get that power from somebody else. All right. Oh, that is all. Thank you so much for hanging out and sticking with me through all of this. I know it was a lot of information. Hopefully, that helps you as much as it helped me really solidify my learning. If you want this PPT, you can find it on vdcsphonehelp.wordpress.com under miscellaneous. Or you can find it on the Vision Data Communication Services Microsoft Teams files. It'll be there as well. Thank you for tuning in, and I appreciate you so much. And I will see you guys in the next one.